Hello, and thank you for joining Futek in this webinar featuring our revolutionary USB Sensic technology. Today, presenters Brandon King and John Vargas will take you through the creation, implementation, and applications that Sensit is designed to tackle. We will have a thorough Q&A session following the presentation, so please feel free to submit your sensor-related questions at any time throughout the webinar. Now let's begin. Brandon?
Thank you, Natasha. Good morning and good afternoon, everyone. I'd like to thank all of you for participating in Futek's USB sensor webcast. Today we're going to discuss how to simplify your system with USB technology. The purpose of this webcast is to discuss the advantages, features, and applications of USB sensors. Some of those advantages include a simplified solution, a complete package, cost-efficient, multiple sensors, and universal applications. The features that we'll review today will also review the Sensit USB Standard and Pro version of our software, and we'll also look into the detail of our data logging, live graphing, and calibration capabilities of that software. The applications portion will be handled by John Vargas, where we'll discuss several real-world applications. He will also discuss the industries in which USB sensors are being used today. Finally, we'll close with a Q&A session at the end of this presentation. So I'd like to start the presentation with the question, why USB? This was an easy question for Futek to answer because we've been supporting product development using USB technology for several years now. Some of the reasons why we chose USB include its ease of use, its package size, a standardized connector, a standardized protocol, and product support for the foreseeable future. The design and manufacturing process, all of our parts are designed 100% in-house. The hardware design and the PCB layout are completed by our engineers as well as the firmware development and software development. The PCB assembly is completed by our qualified vendors, and all testing and calibration is performed in-house at Futek. Now let's review some of the advantages. One of the advantages is that Futek provides a solution that provides simplified system integration. If we compare our traditional solution to Futek's solution, you can see the advantages. In a traditional sensor solution, there may be several components that are required. Some of those could be an analog amplifier or signal conditioner, as well as a precision power supply. It may also require some type of filtering. You would also be using a data acquisition system or data acquisition software for data capture, or also a multimeter or display to view the data. And finally, all these instruments would be connected to a PC. With this system, there's also issues with cable management. A single cable or multiple cables will have to be connected to each of these devices, and also between them. There's also costly components, with especially the data acquisition system in particular. There would also be costs associated with system setup and integration, which can be very involved. The data acquisition system and the software is also necessary for communication if you're going to be using it with a PC. Now let's compare that to Futek's USB solution. We offer a USB module that's a single module, uses a single cable, and can be connected to a PC for communication and for data storage. Our solution is cost efficient. It reduces system noise by removing the amplifier and any digital, and we can also use digital filtering to improve the performance. The power is supplied by the USB bus directly, and the device is simple plug and play, like all other USB devices. Another advantage is the complete package. The Futek USB solution offers a turnkey solution to your application. The USB kit can support Futek sensors as well as other manufacturer sensors. And the USB kit includes a USB module as well as the Sensit USB software, which can be available in the standard or pro versions. The Futek USB solution supports multiple sensors. Our current software supports up to 16 channels that can be connected at one time. We also have the capability for custom designs if you'd like to explore the use of additional channels. Through the use of hubs or computers, we can address up to 127 USB ports. The maximum length of cable between the hubs and the PC is typically 5 meters. However, through the use of USB extenders, this distance can be extended up to several hundred meters. Futek's USB solution offers a complete package. So let's compare the traditional solution to the Futek solution. In a traditional solution, you'd have an analog amplifier or signal conditioner in the range of $300 and a data acquisition system up to $1,500, which would also require calibration at $150. The system software for the data acquisition, which could be optional, could range up to $1,000 and may require a power supply in the range of $150. The estimated setup time and the total support cost could add up to another $300 to the system. Therefore, the total, excluding the software, could be in the $2,400 range, up to $3,400 including the software. If you compare that to Futek's solution, we offer the USB module with our Sensit USB software at $500. We offer the software, the Pro version, for $500 and calibration at $150. The total standard package now is $650 and the Pro package at $1,150. As you can see, there's a significant cost savings compared to the traditional solution to the Futek USB solution. The Futek USB solution is universal. It can be used for all strain gauge sensors. It can support load cells and force sensors, which can be used for tension and or compression measurements. We also support the use of torque sensors for counterclockwise and clockwise torque. We also support pressure sensors, which can be used in both pressure and vacuum measurements. And we also support multi-access sensors, which can be used with several channels of USB. The Futek USB kit provides a solution for many different applications. Now let's compare some of the specifications. The USB 210 offers sampling rates up to 1,000 samples per second. The USB 220 can support rates up to 4,800 samples per second, and the USB 230 up to 14,000 samples per second. With these different sampling rates comes different resolutions. So to match, the USB 210 has up to 18 bits, which is the effective number of bits. The 220 supports up to 22 bits, and the 230 up to 21. So as you can see, the USB 220 has not only a good range of sampling rates, but also covers up to 22 bits of resolution. They all have similar specs for nonlinearity at 0.001%. They have different ranges for the input voltages. The USB 210 supports non-amplified analog signals up to 500 millivolts per volt. The 220 supports the same range, and the 230 up to 1,000 millivolts per volt. Their outputs are all the same. They all are in a custom digital packetized data, and they all support the same minimum and maximum bridge resistances from 50 ohms all the way up to 5,000 ohms. They all use an integrated digital filter for 50 Hz and 60 Hz noise rejection, and we also have an external power supply which is not required for any of the devices. The LED indicators on each of the devices each have a red, green, and blue LED. Red LED is used for the USB data link, the green LED for the adequate power supply voltage, and a blue LED to indicate the microcontroller communication. Each of the devices also have input and output protection for ESD, EMI, and short circuit protection. Let's take a look at the software now. Futek's Sensit USB software comes in the standard version, which we'll review first. Within the standard version, we have the display mode on the first tab. The display mode has a display table, which provides tabular display, which can include information such as the channel number, the status of the device, a serial number, the current reading, and the unit of measure for that reading. In the display mode, we also have functions for a sum channel. Provides a capability for the user to sum the output of several different channels together. We also have a math channel, which can be used to create custom mathematical calculations that can be applied to one or several of the sensor's channels. The USB standard version of the software also contains context menu strips, which are familiar to those that have used Windows applications. From here, this is where you would change the display settings. We can change things from the currently selected channel. We can change between modes for tracking mode, peak mode, or valley mode. We can also reset those modes, so there's a peak reset and a valley reset. We have a tare and gross function, where you can switch between where you tare the reading or look at the gross reading. We have decimal formatting, where you can select the number of digits to display after the decimal from 0 to 10 digits. And we have unit conversion, which will allow you to select different units to convert to within the same type of category, to where you can convert force units to similar force units or pressure units to other pressure units. We have the option to select a sampling rate, where you can change the sampling rate of the A to D. We have average settings, where you can change the averaging mode as well as the number of samples to include in the average. We also have a linearization function, which you can enable or disable a point-to-point linearization. And finally, we have a display refresh rate, which can be selected different rates to refresh the display between 1 and 5 times per second. If we take a look at the math channels, there's also a calculator that's associated with it. So here's an image of the math channel. As you can see, we can select things including the math channel's value, which can either be tracking, peak, or valley value. We specify the math channel's decimal format, and as well as the units, which you have a text box to select or type in the engineering units associated with the math channel. The math channel can also has a calculator and a calculator display, so that you can view the calculation as you build it. Now let's take a look at some of the features for the Sensit USB Software Pro version. The Pro version includes support for data logging. Within the data logging mode, there are several different tabs. One of those being the data logging settings, where we can allow the user to specify the test and duration for hours, minutes, and seconds to run the test for. This is where you'd also specify the file path to save the file to, as well as to initiate a data logging test. On this screen, we're showing the results of one of the data logging tests. We can view the results graphically and view multiple plots for the tracking, peak, and valley of each channel that you recorded during the data logging test. There's also a tab for data logging properties, which will display a table containing the channel number, the status, and the serial number, as well as a data logging table that will display a table containing all of the information related to the test for the sample number, the number of samples in each packet, the actual A to D value, the tracking value, the peak value, and the valley value. And to the right of this screen, which is out of view, would also be the date and time for each of the samples recorded. In the graph section, we also have an option to specify specific values related to the graph. The data logging graph is a very dynamic control. There's hundreds of possible settings that can be applied to manipulate the look or feel of the control. So in order to organize some of these settings, we've created a custom form for the graph options. The graph options form allows the user to change settings that include colors, fonts, the labels for each of the axes, the legend and its location, the series, the X and Y axis settings, and the X and Y axis cursors. Now we'll move to the next feature of the Pro software, which is going to be the live graphing. The live graphing tab is very similar to the data logging in that you can also enter the live graph settings. In this area, this is where you would specify the test duration in hours, minutes, and seconds, as well as specifying a refresh rate, which will determine how often to refresh the screen while live graphing. You'd also create the file path to save the data to, as well as initiating the live graph. As you can see from this screenshot, the live graph allows the user to view the data graphically. You can view multiple plots for the tracking, peak, and valley on the same screen. There's also a live graph table, which I'll show in the next slide, it displays a table containing the sample number of samples in each packet, the actual ADC values, and the tracking peak and valley values, as well as the date and time. The Sensit USB software also has an option for those who would like to do their own calibration. You can contact our sales team if you're interested in doing your own calibrations. From this area of the software, we can do the setup of the calibration, which includes setting up the parameters. You can generate a new calibration test. You can save the parameters and then also save the calibration test data. The parameters have several different fields which can be entered. You can specify the serial number, the number of directions to perform the calibration, 1 or 2 directions, the capacity of the sensor that you're calibrating, as well as the direction of the calibration. You can specify the nominal sensitivity and bridge resistance, as well as the output in engineering units and the number of loading points to conduct during the test, and the number of digits to use after the decimal point. The calibration direction table also allows you to specify or displays either direction that you're calibrating in. So it'll display a different table for calibration direction number 1 and direction number 2. The load will be expressed in engineering units, and the ADC value received from the hardware. The fixture correction for 0, as well as a nonlinearity expressed as a percentage of the reading. At this time, I'd like to hand the presentation over to John Vargas to discuss the applications portion of this presentation.
Thank you, Brandon. In the next few slides, I'll spend a few minutes reviewing some of our USB applications, and we'll proceed to take your questions from there. And as you guys can see from our screen showing some of the companies we've worked with over the past 2 years, we have been able to work with a broad range of companies like Ford, HP, Moog. And what has made this possible is the removal of the intimidation factor with USB. As Brandon emphasized, we can really integrate this product much simpler than some of the existing solutions that are out there. With USB offering a standardized connection, we can take advantage of all the consumer enhancements like USB to Ethernet adapter, which expands the signal for hundreds of meters, USB to wireless converters, where routers pose a challenge. So really for us, it has helped simplify the process and work with a broader range of industries and companies to offer them direct solutions. There's quite a few applications that we have worked on, but we'll cover a few just to give you guys some ideas. Here's an application where we are bringing multiple load cells into a central location. Using multiple load cells in parallel can be a cost-effective method to measure high loads. You also have the added benefit of measuring the load distribution. Another advantage is that you're reducing the downtime simply by modifying the software calculations. So if the unit is damaged or you're sourcing for replacement, this can be easily accomplished as you're just dealing with multiple units as opposed to having just one load cell. Another example similar to this, which is not being shown, is measuring the center of gravity. Customers like shipbuilders would be interested in something like this, or the balancing of helicopter blades during manufacturing. Again, it uses the same concept. We had a recent example that involved load distribution and the activity of lab animals. And here the customer was monitoring the feeding habits or just general behavior. And again, the concept was the same. A series of load cells are paired with USB and our Sensit software to measure these forces. Now, some customers don't have room for load cells in place, so they have to monitor the hydraulic line pressure and then convert that to load. The role of the software here is key, given the right tools to make those measurements possible. Here's an example of a snowshoe test stand that is using 2 load cells to monitor the load versus time. In this case, the software can individually show the customer the toe and heel loads, and of course the total load applied. For those of you who like the show Deadliest Warrior on Spike TV, we recently provided them a solution that was based around the same idea. They were interested in measuring the impact force of a sword on a steel mesh armored suit. Again, using a similar type of load cell, we were able to accomplish this. And again, unique, and application was fun, but a little bit different. We also have customers that have very large multi-channel systems that are not very mobile, so making the testing in different areas very challenging. With the portability factor of the USB, they can easily bring the laptop to the environment to make some of these measurements. And before I go on, I wanted to let you guys know that all these applications are listed on our website. So if you just go to the application tab, you'll find all these illustrations and products that we've used for each environment. For this particular application, the customer had a critical requirement to measure the line tension. And we used one of our smallest load cells for this particular application. This unit is about 1 inch in size, so it's a little challenging to see the miniature size in this particular environment. But as you can see on the illustrations on the left, multiple load cells were used and paired with USB kits, which were then taken to a hub, which fed into a PC. The software could then alert the operator or stop the machine or simply just make a few adjustments. Now, we've talked a little bit about load cell applications, so I'll switch here and provide an example of a pressure sensor. Here, we're measuring differential pressure, and we're using 2 different pressure sensors to measure 2 different medias. We use the software to subtract the measurement or show the difference between the 2 chemicals. And again, this has a very broad reach for anyone interested in mixing materials where pressure affecting how much fluid is dispensed. So you'll find this again to be a universal or dynamic application. Once again, the system software can alert the operator, or the machine can be stopped once the application has hit a critical feedback point. For our last example here, I'm going to show you guys how a torque sensor is paired with USB kit. This customer was interested in measuring the input versus output torque in their system. The Sensit software could then measure both torques and subtract to show the difference. Now, if we were to consider the same approach for a dynamometer-like setup, where the load cell was used with the moment arm to measure the torque, knowing the length of the moment arm, the software could be used to measure and calculate the units to torque. As I emphasized in the beginning, the list does go on and on, from measuring ultra-low forces in springs in milligrams or micro resolution to really high capacity measurements. For engineers in the fastening industries, we can use USB to create a correlation between clamping, load, and torques. For those using multi-axis or multi-component sensors, using USB may be a simpler solution. Here you can again use the Sensit software to measure the load and torques on the same screen. And of course there's a definite cost advantage for this setup. Now before we take on your questions, I want to just show you guys a very simple video of a rotary torque sensor paired with a USB kit. So let's go ahead and show that.